Hey guys, so in this recording, I'm going to go through how we're going to take the work we've done with expressions and use those expressions to build equations. Um, we have four very different types of problems. So more than anything, pay attention to the steps of solving each type of problem. All right, so number one, when 9 is subtracted from a number and then divided by 2, the answer is 4. So first I want to write an expression for the information I know, which is 9. So when 9 is subtracted from a number, so let's say our number is n, when I subtract 9 from it and then divide by 2, the answer is 4. I'm going to set it equal to 4. So now I have my equation and I need to solve it. So I'm going to do this a little bit smaller. In order to get rid of the 2 in the denominator, I'm going to multiply both sides of the equation by 2. So that cancels out. I'm left with n minus 9 equals 8. And then if I add 9 to both sides, I get n equals 17. Great. All right, let's look at the next problem. So Andy is 2 times younger than his sister, and his father is 25 years older than him. If the total of their ages is 53 years, what is Andy's age and his father's age? So this one probably feels a little more like the type of problems we've been doing where there are a number of relationships. So we know that Andy is 2 times younger than his sister. So another way of saying that would be Andy is is a half of his sister, right? 2 times younger is the same thing as half. And his father is 25 years older than him. So the dad or father is going to be Andy plus 25. And since I know another name for Andy, or another way of writing Andy is half S, I can substitute that in for A. So now I can write the father's age in terms of S. So I have a half S plus 25. And then his sister's age, if he's 2 times younger, then that means she's 2 times older. So she's 2 of Andy, or if I plugged in a half S, that would be the same thing as 2 times 1/2 S, which is just S. So it's in terms of the sister here. All of our expressions are in terms of the sister. So for their total ages, I now have Andy's expression, which is 1/2 S. I have the father's expression, which is 1/2 S plus 25. And I have the sister's age, which is S. And all together, their total ages add up to 53. So now I'm just going through the steps of solving the equation. I'm going to combine like terms. I have half S plus S is going to be 2S plus 25 equals 53. Then I'm going to subtract 25 from both sides, and I get 5 minus 25, 2S equals 28. Oops. And then if I divide both sides by 2, I get S equals 14. So then that means the sister is 14. Andy is half the age of his sister, so he would be 7. And his father is 25 years older than Andy, so the father is going to be 25 plus 7, so 32. So there are your ages. Okay, for the third problem, Suni has 3 less than 4 times the number of packets of gel pens, I love gel pens, that Rachel has. Suni pays $2 for each gel pen pack, and Rachel pays $3 for each pack. If the girls paid a total of $126, how many gel pen packs does each girl have? So again, this one is similar to the ones we've been doing, where there's the amount they have and the cost they have. So the amount of gel pack pens, and then the value, and then that's gonna give us a total. So for Suni, she has 3 less than 4 times the number of Rachel's. So 4 times the number of Rachel's minus 3 is the amount that Suni has. Rachel just has the amount she has. Suni pays $2 for each of her packs. Rachel pays $3 for each of her packs. So then for my totals, for how much they spent, the amount Suni bought in terms of R is 4R minus 3. So she spent $2 on the amount she bought, plus Rachel spent $3 on the amount she bought. So there's my expression. I'm going to use that expression to build an equation because I have one more piece of information. I'm told that all together they spent $126. So I can set my expression equal to 126. So I'm going to do 2 times 4R minus 3 plus 3R equals 126. This is where those equation solving skills from the last unit come back into play. I'm just going to rewrite it up here so that I have a little more room to show all of my steps. So remember, with a problem with the distributive property, you can distribute first or divide first. Since 3 is not a multiple of 2, I'm going to go ahead and distribute first. So I distribute the 2, I get 8R minus 6 plus 3R equals 126. I'm going to combine like terms, so I have 11R minus 6 equals 126, and then add 6 to both sides. I get 11R equals 132. So then R equals, if I divide both sides by 11, R equals 12. And the question was asking, how many gel pack pens does each girl have? Well, Rachel has 12 packs, and Suni's is 3 less than 4 times Rachel's. So Suni is going to be 4 times 12 minus 3. So 48 minus 3, which is 45. So Suni has quite the collection of gel pack pens. Rachel has 12 packs, Suni has 45. Okay, and then the last problem is a rate problem, which we've also come across with our expressions, right? Because the rate and the amount of time is still going to give us a total distance. So I can still set it up in a similar table. So Edward leaves his house. He's traveling west at 50 miles per hour. So Edward's rate is 50 miles per hour. 2 hours later, his husband leaves their house in a car traveling 40 miles per hour in the opposite direction. So the husband's rate is 40 miles per hour. And so I'm going to also just add a little diagram here so I can see what's going on. So here's their house, right? Edward is traveling in one direction at 50 miles per hour. And his husband is traveling in the opposite direction, going 40 miles per hour. The additional piece of information we have in terms of the time is that the husband leaves 2 hours later. So if I'm writing the distance in terms of, so distance is going to be their rate, the speed they're going, times time, right? So for Edward, his time is t. His husband left 2 hours later, so his time is going to be t minus 2. So now for the total distance, well, for Edward's distance, it's going to be 50t. That gives me this distance here. And then for the husband's time, it's going to be 40 times t minus 2, which will give me the distance going this way. So for the total distance they are apart, I'm just adding those two expressions. So 50t plus 40 times t minus 2 gives me the total distance they're apart. Unlike just the expression problems, I have one more piece of information. Find the amount of time the cars drove when they were 910 miles apart. So this total distance is going to be equal to 910 miles. So now I just need to solve and break out those equation solving skills again. I'm going to distribute the 40. So I have 50t plus 40t minus 80 equals 910. I'm going to combine like terms and get, 90t minus 80 equals 910. I'm going to add 80 to both sides so that I have 90t equals 990. And then if I divide both sides by 90, t equals 11. And so just to make sure I'm answering the right question, I'm going to go back and it says find the amount of time the cars drove. So remember, t was the amount of time that Edward drove. So Edward drove for 11 hours and the husband drove for 2 hours less, so he drove for 9 hours. There's my answer. Great. You're going to practice this same idea of making an expression and then setting it equal to an amount and solve. So your steps are going to be to write the expressions, set the expression equal to an amount, solve for the variable, and then answer question. This last part seems obvious, but it's kind of an important one to go back to because in this problem that we just did, I solved for the variable, which was t, but that's not the end of the answer. The question is asking the amount of time the cars drove. Well, Edward's car drove for 11 hours, but his husband's was 2 hours after Edward left. So, oops. So I had to subtract 2 to get 9 hours. So make sure you're answering the question that the problem is asking. Feel free to go back and watch any part of this lesson again, and then you'll have a chance to practice what you've learned. See you guys in class on Tuesday. Bye.